Hello everybody, this is Docker Community All Hands Season 4 and my name is Anamika. Today I will be speaking about packaging an application using Docker. First of all, I would like to thank all the organizers of this event for letting me in. And secondly, huge shout out to all the audience whosoever has joined in today. It truly means a lot. So let's get started. I'll share my screen first. Okay, so I hope my screen is visible to everybody. So this is Docker Community All Hands Season 4 and my name is Anamika. I'm a final year student pursuing my BTech in Computer Science and Engineering. I'm a cloud native scholar and community member at Suze and Rancher community. If you wish, then you can reach out to me. These are my handles. I will be very happy to get connected with you all. So yes, today I will be speaking about Docker for application packaging. This session is going to be in the Get Started track. And in this talk, we will discuss how an application can be packaged using Docker. We will explore the Docker components along with the total workflow of application packaging. Then in this talk, we'll also look at the overview of some tasks or goals that cannot be that can, first of all, we'll look at the task goals that can be simplified by the use of containerization technique. And towards the end, we will also have a look at some of the tasks which cannot be done, which cannot be completed, or some of the goals which cannot be achieved by just using containerization for our application. So it is not going to be a single-sided thing. We'll be looking at both the faces of the coin. Also, we will be having a giveaway in the middle of the talk. So keep hanging in there, and the details of giveaway I will provide very, very soon. So yes, let us move forward. So the agenda for this session is as follows. First, we will look at the containerization and virtualization terms. I know that many of the people here would already be familiar with these terms, but since this talk is in the Get Started track, so I want to start from the beginning and have a brief look at these terms so that even if a beginner or a newbie who's just starting, who is unfamiliar with these terms, can also feel comfortable and can learn something from this track. So yes, we will be having a brief overview. We'll be looking at these terms, containerization and virtualization. Then we will look at the Docker components, and then comes the main part, which is packaging and application. We will see that how the different Docker components are involved in the application packaging and how they all collectively contribute towards the release process of an application. Then we'll look at the total workflow, like from the initial to the end, like from zero to hero, like we can say like that. So we'll look at the workflow, and then we will be having a giveaway. So in the giveaway, what we're going to do is that I will be asking a simple question and you need to answer it. It's so simple. I have something to give to the audience, and the first one to answer correctly will win. So a pro tip from my side, that be fast, because the question is going to be super, super simple, and therefore the answer is also going to be extremely simple. So you just need to do some fast tappings. Consider it like a fastest finger first kind of thing. The first one to answer correctly will win something exciting. And towards the end, we will look at some of the tasks or goals that cannot be achieved with the help of containers, or and some scenarios in which we cannot use containers for the simplification of our processes. Okay. Yes. So what is virtualization? So virtualization, consider it like it separates the hardware and the operating system of a computer. Like in a computer, there is the hardware and there is the OS, and they are tightly coupled together. So what virtualization does, it separates the tight coupling between the hardware and the operating system, and it It does this by creating an abstraction layer between the hardware and operating system, which is known as the hypervisor. So virtualization separates the tight coupling between the hardware and the operating system by making use of an abstraction layer, which is known as the hypervisor. Now, what is the use of the hypervisor? This hypervisor emulates all the functions of a real computer and its CPU in a virtual machine. So a virtual machine can be thought of as a place where we are actually running an instance of an operating system on top of another operating system. And there's usually a layer which is called as a hypervisor, which is a program actually that takes an operating system and runs it on top of another operating system. So you can see that these are the virtual machines. This hypervisor, it has emulated all the functions of a real computer and its CPU inside a virtual machine. And now we can run multiple virtual machines on hypervisor, and each virtual machine can run any compatible operating system such as Windows or Linux. So in this figure, you can see that there is the hardware, and then there was the operating system. This one, the hardware and the operating system, and the abstraction layer, which has been created by virtualization technique, which is called the hypervisor. And now this hypervisor emulates all the functions of a real computer in a virtual machine, and it can now run its own compatible operating system. Now, don't think that this is the only operating system. No, there is a host operating system here too, on which these guest operating systems are running, right? So this is a mapping. This is an overall mapping of the hypervisor, the guest operating system, and the host operating system. Okay. So now you can see that this. What is the use of containers in it? We already have everything running. Then why do we use containers? So as you can see in this picture here, so if we have three virtual machines and they all have applications running on it, they all have their guest OS, which is running on the hypervisor, which is mapped onto the host OS. So now this is a big process. This is a big process because uh, each virtual machine has their own application and their own operating system on which the applications are running, and all of that is running on a hypervisor, which is again running on a host operating system. So you can see that this is a big process, and it is a heavy rated process, and it uses quite a bit of resources. Like, it is a costly process. Now when I say costly, it does not only mean money. When I say costly, it means three things. First is resource, second one is time, and third one is money. So it is a costly process, all in terms of resources, time, and money. So this is where containers come into picture. The idea of containers is that it strips down the whole process into even more layers, thus making the whole process easier. Okay, so when you use containers, you don't need to run a full operating system on top of a layer that maps into the another operating system. Like in the virtualization thing, what we're doing, we are running our operating system on top of a layer which is hypervisor, which maps it to the host OS. But while using containerization, we do not need to do that. Containers run as process in the host operating system. It looks like any other simple process which is running inside it, to the operating to the host operating system. The containers look like just another simple process that are running inside it. So by using containers, it involves a much lightweight approach to deploy an application and its dependencies. And also, we do not have to have a full infrastructure of a physical machine and a virtual machine. So using a container is very, very disposable. Okay. And also there are other benefits which are associated with containers, like higher speed, which we will look at later when we'll talk about the Docker file and Docker image, and we will see that how it provides high speed. Basically, it uses a method called caching. So by the use of that particular method, it provides a higher speed. Then also it is easily portable. When I will talk about Docker, then I will say a very famous developer line, which everybody would be familiar with. So yes, there's the using containerization technique. By using containers, it is easily portable, then it is platform independent, it has higher efficiency, and of course lower computing cost and cost in terms of money, time, and resources. So now, where does Docker fit into the picture? So the appearance of containers has enabled organizations to ship products using a lightweight mechanism that would make the most of the available infrastructure. So there are plenty of tools. Docker is not just a tool. There are many more tools which are used to containerize services. However, Docker has set the industry standards for many use. Okay, so in simple terms, this is Docker Community All Hands, and I am very sure that everybody knows what Docker is. But still, in simpler terms, I will say that Docker is a very popular containerizing tool that simplifies the process of building, running, managing, and distributing the applications. Okay, so now we will just jump onto the main part. We'll not give much time to what Docker is and why is it used, how it came into picture, because Docker Community All Hands, everybody knows what is Docker. So let us directly jump to the main part, that understanding the working of Docker. So just now I said that Docker allows us to build, ship, and run any software. So in order to ship and run, we need to build first, and in order to ship, we need to build and run first. So there are mainly two concepts in Docker: image and container. So let us look at the Docker components one by one. So to containerize an application using Docker, three main components are distinguished: the Docker files, the Docker images, and Docker registries. Let us explore each component in a bit more detail. So first one is the Docker file. A Docker file is a set of instructions used to create a Docker image. Okay, so it is normally a text file. It is nothing more than that. If you want to create a Docker file, you just name it Docker file and it is created. No extension, nothing. Just name it Docker file. So it is a set of instructions which is used to create a Docker image. And each instruction in the Docker file is an operation that is used to package the application, such as installing dependencies, compiling the code, or maybe impersonating a specific user if you go to a little bit more advanced thing. So here is a simple example of Docker file. Um, so you can see that the first thing is from. So this is the most important thing, and every Docker file contains this statement like to set the base image. Basically, to set we want to set a base image according to our application. Like if for a very basic application, we can use Alpine, which is the most basic image, and for our other applications, we can use base images which correspond to our application, like whatever we need. So to set the base image is the most important thing, and it is the first line written in any Docker file. Now to run is used to execute a particular command. Like suppose for running an application, you need to install some dependencies or some requirements which are present in a requirements.txt file. So you need to install all the requirements first. So in run, you can just say pip install requirements.txt. So all the requirements and dependencies or whatever you need for your application will be installed. Again, it is application specific, like what you want in your application, you can use that. Now, copy and add. Copy and add are very important actually, because it is used to copy files from host to containers. Now you might ask that why do we need to copy files from host to containers? Container is inside the host, so it automatically has access to all the files inside the host? No, it is not so. Containers run as processes in the operating system. They do not share the operating system, right? They are just different processes, and one container do not have access to anything which is outside of it. So if we want a particular file to execute, if you want to execute a particular file or a particular application inside a container, we need to copy those from host to the container. If we do not copy your files and directories inside the container from the host, it will not execute. Just try it, it won't execute. So this is actually very easy, and the reason is also very simple because containers run as processes in the host operating system. So we actually need to copy all the resources because the container by itself does not have access to any of the resources which is outside the container. And now CMD is used to set the default command to execute when the container starts, like npm start or to open the command prompt, or it can be anything. It is again very application specific. So yes, and then expose is used to export an application port. So if you want to expose your application to a particular port, you need to use expose, otherwise your application won't be reachable on that particular port. So this was about the Docker file. So now that we have created our Docker file, the next thing is to build the Docker file in order to create the image. So now we need to build the Docker file. So a Docker image can be built from an existing Docker file using the Docker build command. Okay, now this is the syntax for the Docker build command. Docker build options path. Here options can be -t, -f, or double build -r. So T is used or tag option is used to set the name and tag of the image. Okay, tagging an image is very, very important. We will look further when we further proceed with the talk, then we will have a look at why tagging is important. So this and tagging option, just keep it in mind, it is very, very important, and sometimes it is a must. It is a must to use, like when you are pushing images to a public repository in order for other developers to have access to your image, you need to tag the image. It is compulsory. Basically it gives a version control kind of thing, and it also provides an ID to the image which is in more human readable form. Okay, so these are the options, and if you want to find all the valid options for the Docker build command, you can just use this one, Docker build help. It will give you all the valid option for this command, which is Docker build. Okay, so the next one, after building and before distributing the Docker image to a wider audience, it is always advised to test it locally and verify whether it meets the specific requirements or not. So for that, we use Docker run. So to create a container using an available Docker image, the Docker run command is available. This is the syntax for the Docker run command: Docker run options, image, command, and arguments. Okay, so here options can be detach, which is used to run in background. Basically, your your container will keep running, and the image, like the running process, the creation process of the image will take place in the background. Now P is used to expose the container port to host. As I already told, if you want to expose your application to a particular port, you need to use the P tag. And IT is used to start an iterative interactive shell. Okay, so again, if you want to find out all the valid options for this Docker run command, you can just go to docker run -help, and all the valid options can be found. So the next is there are some additional commands also, like to access an application in a browser, we need to bind Docker container port to a port on the host or local machine. Can you say why this is important? Like, why do we need to bind the Docker container port to a port on the host or on our local machine? Why is it important? I have already told that because containers do not have access to anything which is outside of it. If you do not bind the port, you will not be able to access your application. Just try it out. This in this session, basically time is limited. If sometimes later I get more time, or if I get more more sessions to connect with you all, I will definitely be very happy to show you these, actually show you these, because when I was learning Docker, I actually did these mistakes and then I learned. So yes, the hyphen p is very useful if you want to access your application on a particular port. Also, to retrieve the Docker container logs, you can use the Docker logs and container ID command. So container ID is basically the ID that you will get after building your image. Again, logs are very important when you are building an application. Logs are very important. Let me tell you how logs are very important. Like just consider that you are building a website, okay, and you did some changes. The website is working perfectly fine. You did some changes, you just hit the refresh button and it shows 404 error. Now you don't know where is the error, like what did you do wrong. There are no logs. But when you add the logging functionality, you can actually see on the terminal that where did your website break. So it becomes more easier to work with while having a logging functionality. So you can use Docker logs and container ID command to retrieve the Docker container logs. Okay. Now the next component is the Docker image. So once the Docker file is constructed, these instructions which are given in a Docker file are used to build a Docker image. A Docker image is a read-only template that enables the creation of a running instance of an application. So it is just a read-only template. Basically, Docker image uh, is used to create containers. Okay, when the image runs, the running instance of the image is known as the container. So the sole purpose of the Docker image is to run the containers. Okay. In a nutshell, you can say that Docker image provides the execution environment for an application, including any essential code, configuration files, or any other dependencies. Okay, so we already know how to build a Docker image. A Docker image can be built from an existing Docker file using the Docker build command. So first you need to write the Docker file, and then using the Docker build command, you can build the Docker image. So now again, I have mentioned it earlier, I will mention it again, that before distributing this Docker image to a wider audience, it is always advised to test it locally and to verify if it meets specific requirements or not. So to create a container using available Docker image, Docker run command is available. You can test it locally. You can test it on your machine, whether these images are running properly, whether the requirements for which these Docker files and these Docker images were created, those requirements are being satisfied or not. So it is always advised to first test before distributing your image. Okay. Now the next part, and also the last step in packaging an application using Docker, is to store and distribute it, right? Is to store and distribute it. Now, so far what we have done, we built the image, we ran and tested the image locally. We ran and tested the image locally. But now on a local machine, developers from all around the world do not have access to that image. Or engineers from all around the world do not have access to our image that we have tested on our local machine. So, which it does not ensure that this image will work properly there also. So there was a very famous developer line, let me say it. So before Docker came into picture, like there was a kind of meme or a joke, like it is working on my machine. So the person A says it is working on my machine. Then person B says, but it is not working on mine. Then person C says, but it is working on mine. So person B again says, then should I give your machine to the user? So this was like a joke, and all the developers must have heard it. And Docker community, I think everybody has heard it. So yes. So in order to share our image, our local image that we have built and tested, we need to push our local image to a public Docker image registry. Okay, so that developers or engineers from all around the world have access to our image that we have created. Okay, so the image needs to be pushed to a public Docker image registry. The registry can be anything such as Docker Hub, Docker Harbor, Google Container Registry, and there are many more. There are many more. Docker Hub is most popular, I guess, but there are many other, public Docker image registries, and sometimes it might also be the case that one image should be private and only available to some certain trusted people or some trusted parties. So the team can, in that case, a team can also host private image registries, which provides full control over who can execute and access the image. So here comes the important part that I was saying, that why tagging is necessary. So before pushing an image to a Docker registry, it is highly recommended to tag it first. Okay, you need to tag an image before pushing it to the Docker registry. So why is it recommended? Because during the build stage, if a tag is not provided via the -t or double -tag flag, then the image would be allocated an ID which is not in a human readable form. Okay, if you do not tag the image, then the image will be provided an ID which is not in a human readable form. And on the other hand, when you use a tag, when you tag your image, then uh, the the image is readable by the human eye. Basically, it will be given an ID which is in the form of the registry repository, the image name, and the version. Okay, so this ID is human readable, whereas if you do not tag the image, then it will be given an ID which cannot be read by humans. So you might also ask them, why do I need to uh, read the ID? Why do the IDs, image ID, need to be in human readable form? So here's an example. Suppose I have built a product called P. Okay, I have built a product called P. Now I have released an update for a product P, which is called P.1. Okay, so P.1 is an update for the product P, and clients are using it, customers are using it, and it is super stable, works totally fine, super smooth, everything's fine. Now I'm working on it, and I again release an updated version, product P.2. Okay, so now this product P.2 is not stable. Like, it does not work correctly, it breaks, customers are having issues, clients are having issues. What will you do? You will work on that. You want to make it stable, you want to make the final release, which is product P.2, stable. So that does that mean that till the time you do not make it stable or you do not clear the errors, the customers have to like use the broken product only? No, it's not true. You need to revert back to a stable product. You need to revert back, right? So for that case, tagging is useful. So like the P.1 and P.2 are considered as tags, and if a specific tag, which is P.2, is broken, which is not stable, not meeting the requirements, not satisfying the needs, we can easily roll back to a previous release, to a previous tag. So tag provides version control over application releases, and a new tag will indicate a new release. Okay, so it is same like Git and GitHub, where commits are used to see the whole process. Like, this commit was fine, then a new commit takes place, it is not good, then revert back to the older commit. So it is the same way. Okay, so yes, this was all. Now the workflow was that first we need to create a Docker file, then we need to build a Docker file and create Docker image. So the image is the most important thing in the Docker world. The image is used to create a container. The container can be thought of as an instance of an image. The Docker image is a static thing. It is not a process in the memory, it is just a template, read-only template. The sole purpose of a Docker image is to run the process. And keep in mind that there are only three things that can be done with Docker image, which is to build it, to launch a container using image, and to delete the image. So images can be built with the help of Docker file. A Docker file is a plain text file which has some lines of configuration placed inside it. And these configurations decide the behavior of the container or what it does upon starting up. The next step is to build a Docker file using the command called docker build, which we saw here. Docker build, okay. And the final step is to run the build file with the help of the docker run command. So every time we deploy an image, we get a running instance of the image, which is called the container. So yes, this was in simple terms in how we can actually use containers and run them by creating and deploying images, and how we can package any application with the help of a Docker file. So first we need to create with the help of Docker. So first we need to create a Docker file, then build a Docker file, run it to test it locally. Then image is created, and here basically these layers that you are seeing in the image, these are the operations which are mentioned in the Docker file. Like these commands from run, copy, cmd, expose, these work as layers, and these layers use caching. So you will notice when you first build and run an image, it takes more time than the second time you do the exact same thing, because it uses caching. Unless and until you delete the image from your system, it will use the cache thing. And if any layer is updated, then it will just update that particular layer and use caching for the other layers. Okay, so and then after running and testing it locally, we push it to a public Docker registry so that other users and other developers from all around the world can make use of it. Okay, so yes, here comes the exciting part, which is the giveaway part. So be the first one to answer and you can win a cool Docker t-shirt. Okay, so the rules of the giveaway are very simple. In the next slide, I will be asking a question. Okay, and the first one to answer in the chat correctly will win this t-shirt. Now meanwhile, if you have any questions about the topics that we have discussed so far, about anything which I said which is unclear, or about any slide which I showed and it's unclear, please ask your questions in the chat section. I am here to answer your question. All your doubts will be cleared, all your questions will be answered. Please put your questions in the chat section. I will answer all the questions. Do not hesitate to ask anything. No question is stupid. No question is bad. Feel free, because this is the get started track. If you don't ask questions in the get started track, then where will you ask questions? So feel free to ask questions. I am there. I will be answering all of your questions. Okay, and if everything is clear, then just get ready for the giveaway part, because you need to be fastest. So I will show the next slide. There will be a question in the next slide and you have to answer it correctly. Basically, it's a very simple question. Trust me, it is a very simple question, and we have one single Docker t-shirt, and first one to answer correctly will win that t-shirt. So just keep yourself ready, and I'm going to change the slide. This is like fastest finger first kind of a thing. And let me give you a hint. The length of the answer is, no, I won't give that. I won't give that. It is a very simple, that be a clear hint actually. No, I won't give that hint. Okay, so the question is very, very simple. Just be ready. Keep your fingers on your keyboard. I'm going to change the slide in 3, 2, 1. Is virtualization dead? That is the question. Is virtualization dead? What do you think? Answer in the chat. Like, it's time to think. Come on, think. We had so much discussion about containerization, how it is beneficial. Everything is simplified by use of the containers. Everything is simplified when Docker came into picture. So why do virtualization is not needed, right? So is it dead? What do you think? Is it still there? I don't know. Answer and you can win. So waiting for your answers. Okay, So let us see what the answer is. And the answer to this question is no ways. Is virtualization dead? No ways. Is containerization better? For some use cases, yes. Containerization is better because it has lots of benefits like higher speed, portability, platform independence, lower computing costs, but that doesn't mean that virtualization is dead, right? Even before containers or Docker came into picture, like Docker came into picture in 2005, before that also we were using applications, we were sharing our application, we were shipping our applications, we were not using containerization tools, but all the things were happening, right? It was not blank. So virtualization is not dead. Remember, it is always getting a proper tool for a particular job. It is always about getting a proper tool for a particular job. In some cases, I have seen they only use virtualization technique for their production and for their environment. And in some cases, they even use hybrid, like some parts need virtualization, so they use virtualization. Some parts need containerization, so they use containerization. Most definitely, never say yes to this. Is virtualization dead? No ways, never ever. Virtualization is still in picture and it's important in some use cases. Okay, coming to the last part, what containers cannot do. So we have seen lots of things that containers can do. Let us look at the other side of the coin, that what are the things that containers cannot do. So containers won't fix your security issues. Do not use Docker if you prioritize security. Why? The greatest Docker security advantage is that it breaks the app into smaller parts. So if the security of one part is compromised, the rest of them will not be affected. But while isolated processes in containers promise improved security, remember that all containers share access to a single host, right? Containers are isolated, but all the containers, they share access to a single host. That is your operating system. So you risk running Docker containers with incomplete isolation. Any malicious code can get access to your computer memory. Again, do not use Docker if you develop a desktop GUI application. So Docker does not suit applications that require rich UI. Docker is mainly intended for isolated containers with console-based application. GUI-based applications are not a priority. Their support will only rely on specific case and application. So one thing I found out on the net is that Windows containers are based on either Nano or Core server, so it does not allow users to start up a GUI based interface or a Docker RDP server in Docker container. So Docker is not helpful if you want to develop a desktop GUI application. Then again, it does not turn application magically into microservices. Yes, do not expect to containerize your application and to magically turn it into microservice. No. What will you have? What will happen if you put a monolithic application inside a container? It will only it will just be a monolithic application inside a container. It won't turn into microservices. It is not magic. So it does not turn, just containerizing your application won't turn into microservices. And last but not the least, it is not a substitute for virtual machines. Don't ever think that. This session was focused on containers. We have looked at the aspect of containers, but that doesn't mean that containers or Docker is a substitute for virtual machines. No, they are in use and they are important sometimes. So yes, that was all about the session. Hope you all liked it. And if you have any questions, please ask them in the chat section. I am here. All of your questions will be answered. Thank you so much for joining with me today. I hope you had a great time. I had a great time sharing my screen with everybody. And let us meet soon. Thank you. Take care. Bye.